afternoon. Welcome to chemistry lesson. And in today's lesson, we are going to discuss about anions. What are anions? Anions are negatively charged ions. Then, the objective of this lesson is that at the end of the lesson, we must discuss the test for 4 types of anions which I've written on the board here. You can check and see. We are going to discuss about these 4 anions: sulfates, sulfides, carbonates, and chlorides. So as you can see, their chemical symbols, they are negatively charged anions. Thank you. Also, I can take you through the chemicals that I have with me here so that we familiarize ourselves with them. Okay, let me start from my right here. So this is a solution containing now the sulfate ions. This is a solution containing the sulfide ions. This is the solution containing carbonate ions. This is the solution containing chloride ions. Then the other solutions, the other 5 solutions, that is barium chloride solution, lead nitrate solution, dilute hydrochloric acid solution, dilute nitric 5 acid, then acidified potassium permanganate 7 solution. So these 5 solutions will enable us to identify these 4 anions. Is it okay? So straight away I would like to start. So let us focus now. When we test for anions which are negatively charged ions, I'll start by testing the first 3. That's the test for sulfate, sulfide, and carbonates. Then we ask ourselves this question: which solutions are we going to test for the presence of the 3? Very simple. We use barium chloride solution, or we can use barium nitrate solution. Is it okay? So you add 2 to 3 drops of barium chloride solution, and as usual we will have the observation column and the inferences column. So in case you add, then you form white precipitates, we suggest the presence of the sulfate ions, sulfide ions, and carbonate ions present, we suggest. So straight away I'll start to perform the experiment. So you take a clean dry test tube. Then this is a solution containing the sulfate ions. I take about 2 ml. What is the color? Colorless solution, clear solution. Then I take barium chloride solution using a dropper. Then I add exactly 2 drops. 1, 2. What do you observe? What do you see? Formation of white precipitates. Is it okay? So if that's the case, then we suggest that if white precipitate forms, we suggest sulfate, sulfide, carbonate ion present. But we know these are what? Sulfate ions. Is it okay? Then the next step, with the white precipitates above, add drops of dilute hydrochloric acid or dilute nitric 5 acid. Then if white precipitates do not dissolve, then we suggest the presence of the sulfate ions. So these white precipitates containing the sulfate ion, I add there a few drops of dilute hydrochloric acid and see if the white precipitate does not dissolve. Is it okay? Let us go. Then using a dropper, I take dilute hydrochloric acid. Then I add several drops. Let us go. 1. And every addition you have to shake. 2. You shake thoroughly. Like that. Like that. Continue adding. Continue adding. What happens? The white precipitate does not dissolve. So, white precipitate does not dissolve, sulfate ion present. Thank you. Let us move on to test for sulfides. You can see the chemical symbol, sulfide. So this is a solution containing sulfide ions. I take about 2 ml or 2 mils. Then the first step, we add first barium chloride solution dropwise. Initially the color containing the sulfide ion is colorless. I add exactly 2 drops. 1, 2. What do you observe? Formation of white precipitates. Is it okay? Then the next step, to the white precipitate above, add drops of dilute hydrochloric acid or nitric 5 acid, but we are using dilute hydrochloric acid. So I take some drops of dilute hydrochloric acid, then I add to the white precipitates. 1, 2, 3, 4. You can see that the white precipitates have dissolved. So what happens to the white precipitates? White precipitates dissolves to form a colorless solution. So if that is the case, white precipitates dissolves when we add dilute hydrochloric acid. Then we suggest the presence of the sulfide and carbonate ions present. But what we know is that this is a solution that contain what? Sulfide ions. Is it okay? So we confirm the presence of the sulfide ions. The next, I take another dry clean test tube. Then this time around, I use a solution containing carbonate ions. I take about 2 ml. I have to measure about 2 ml, but this is an approximation. This is about 2 ml of carbonate ions in a solution. What is the color? Colorless solution. First step, we add barium chloride solution dropwise. So using my dropper, let me add exactly 2 drops. Just go 1, 1, 2. What do you see when we add barium chloride solution? Yes, formation of white precipitates. Formation of white precipitates. The next step, to the white precipitate above, add drops of dilute hydrochloric acid or nitric 5 acid. But I'm adding dilute hydrochloric acid dropwise. So this is now dilute hydrochloric acid. Using my dropper, and as I add, we have to make the observation. Let us make the observation. Let us go 1, 2, and also you will see some gas bubbles, what we refer to as effervescence. As I add the acid, you see the effervescence. you will hear the effervescence and you see the gas purple, the hissing sound. Meaning that there is evolution of a gas, and because this is a solution containing carbonate ion, that is carbon dioxide gas being evolved. That's why you hear the effervescence. And this one requires your patience. Patience is very important when you perform this this experiment. Just watch and see exactly what is happening to the white precipitates. Effervescence are there, or gas bubbles. Then the white precipitate dissolves to form a colorless solution, a clear solution, as you can see. Then we also suggest, if the white precipitate dissolves, when you add the drops of the acid, we suggest also the presence of the sulfate and the carbonate ions. But in this case, these were the carbonate ions. So it means that the precipitates of the sulfite and the precipitates of the carbonate, that is white precipitates, will always dissolve when you add some drops or several drops of the dilute hydrochloric acid or dilute nitric 5 acid. Is it okay? But now, how do we now distinguish between sulfite and carbonate ion? Very simple. I've written here to differentiate between sulfite and carbonates. We add acidified potassium permanganate. So this one will assist us to distinguish between sulfite and carbonate ions. Straight away, let us go and see. So what we do, I take a clean dry test tube. Then I take 2 ml of acidified potassium permanganate solution. That's about 2 ml. Then, what am I going to do? I want to add a solution containing sulfide ion and see the effect on this purple color of acidified potassium permanganate 7. And it is good that I use a dropper. So, I take a solution containing sulfide ion. Then I add to purple potassium permanganate 7 solution. Let us go. 1, 2, 3, 4, and this one requires your patience, please. 5, 6. Those are 6 drops. Then you continue adding and see. And also observe the changes, please. There are about 7 drops. So what has happened to the purple color of potassium permanganate? It has been decolorized. A colorless solution forms. Is it okay? So it means sulfite ions will decolorize acidified potassium permanganate 7. Is it okay? Thank you. Let us see a situation whereby we use now a solution containing carbonate ion. First of all, I take 2 ml of acidified potassium permanganate 7, as I've done in the first one. Then this time around, I use a solution containing carbonate ion and see if this one will also be decolorized, just like sulfide ions. Let us go. So after every addition, I shake. You can see the effervescence. These are carbonate ion, then this one is acidified, so effervescence must be observed. In fact, I'm adding in excess now. I've now added excess, and the test tube is almost full, you can see, but no decolorization. So potassium permanganate 7, the acidified one, do not decolorize. So it means carbonate ions do not decolorize acidified potassium permanganate 7. Is it okay? You have seen. And that is how we normally distinguish between the sulfide and the carbonate ions. Carbonate ions do not decolorize acidified potassium permanganate 7, while the sulfide ions decolorizes. Is it okay? Then finally, without wasting time, I can also check on the test for chlorides. I want us now to look at the test for chlorides. So to test for chlorides, you can now focus here and see. To test for chlorides, I've written here, test for chlorides, we normally use this solution of lead 2 nitrate, a solution of lead 2 nitrate, so we add dropwise. Is it okay? Then if you add dropwise, we have the observation, or before you go to the observation, when you add lead 2 nitrate, it is very important that you also warm. So addition of lead 2 nitrate dropwise, it is followed by warming. Is it okay? Then on the observation, if the white precipitate dissolve on warming, then in the inference we say chloride ions present. Okay, let me put on a flame of the Bunsen burner. Let me put on the flame of the Bunsen burner first before we continue. So this is the non-luminous flame of the Bunsen burner. Then I take another clean dry test tube. Then I take a solution containing the chloride ions, about 2 ml. That's about 2 ml. Is it okay? Then I add there a solution containing lead 2 nitrate solution. I add, but dropwise. I'll put there about 3 drops. It has got 1, 2, 3. What do you observe, or what do you see? Formation of white precipitates. So to confirm if these white precipitates are due to the chloride ions, it is followed by warming. I need to warm on the flame. Is it okay? And warming, you just be patient. Be patient. Then you focus here clearly and see as I warm this one. What will happen to the white precipitates? What will happen to the white precipitates? And I said this one require patience. You warm gently. Just observe and see. Test for the presence of chloride ions. Testing for the presence of chloride ions. After warming, what has happened to the white precipitate? White precipitate dissolves to form colorless solution. Test for chloride ions. We have come to the end of this lesson. Hope you have enjoyed the lesson. So in the next lesson, I'll be talking about flame tests. Flame tests. Thank you. Thank you.